I'm the Associate Professor from Institute of Computer Science and also Digital Innovation from UCSI University. And previously I was in University Technical Malaysia Melaka for about 15, 16 years. Yeah. Okay, before we go to software agent, we're going to look into what are the things. Sorry?
Can you slide show your slide full screen?
Oh, make it full screen. Yeah?
All right. Okay, thank you.
Is it okay?
All right.
So basically the title is, do we need a software agent? So after you listen to my talk later on, and I believe that before this you have already what do you call this, listen to a lot of webinar sessions, a lot of talk sessions about artificial intelligence, about techniques in artificial intelligence, methods in artificial intelligence. So I believe that, of course, you have some knowledge on the techniques, the methods that currently being used in artificial intelligence. Yeah? So now I just give you some introduction actually for this session, because in 1 hour we cannot get into very deep on software agent. Yeah? So my talk is going to cover on introduction of agent. Yeah? Some people say agent, some people say multi-agent systems, some people say it's intelligent agents, some software agent. So we are going to look into first the motivation why actually we want to use agents, yeah? And then also we are going to look into definition of agent, what are the agent characteristics, taxonomy, and then the relation between agents and objects. Then we go into multi-agent system. What is multi-agent system? Agents intelligence, then areas of R&D in multi-agent system, and exemplary application domains. Yeah? So I believe there are, this is just introduction or just a brief introduction to what actually agent is. Yeah? So motivation for agents, what are the motivation that why actually we want to use agents? Yeah? So large scales, complex distributed system, and because currently we can see that we have the system which is built in large scales, we have the complex system, distributed system, and then how to understand and build and manage all these kind of the system. Yeah? So by actually this kind of system like large scale, complex, distributed, we also can use agent as part of that system. And then now also we have open and a heterogeneous system, means that we can build components independently, means that we build independently one system, another system, and then another system, but we can interact within the system or with the other system, we can interact with each other via the communication between the system itself. And then also we have a distribution of resources. Nowadays, there are a lot of resources when we talk about resources. Yeah? It can be resources, for example, like computing, computation resources, for example. Like we have a very high-speed CPU, we have high-speed processor, all that you can say as a resources. Or maybe we have, currently we have resources, for example, like in different area we have like space storage in different location. So how we are going to integrate in different what do you call this, we have different distribution of resources and how we can integrate with each other. So by using software agent, it can help as well. Yeah? And then distribution of expertise, because throughout the whole world we have a person that have a different expertise. Yeah? So how we can what we call this use them even though they are in different places, that how we can get together and try to use the expert from distance. And then also the current system, the current what do you call this personal system that we develop nowadays, we want to personalize and also we want to customize the system according to what the user want, yeah, what the user need. Because we not necessarily build a general system, but we can personalize and also customize according to the user's need. So by having the agents, yeah, or part of that, then we can make it happen. And then interoperability of pre-existing system and also integration of legacy system. Because of course, when we have a new technology, or we have what do you call this, a new system, a new way of doing it, a new, for example, like nowadays people are using app, mobile app and everything. But even that, we cannot forget about the legacy system or pre-existing system that we have, that we cannot replace that existing system or legacy system. But so that things we need to how to integrate between the system that we want to propose or something new technology that we have with the pre-existing or the legacy system, and we need the mechanism. So by having the software agent, it also can help this kind of system. Okay, what is okay? What is agent actually? The term agent is used frequently nowadays in sociology. Yeah, in sociology we use agent. In biology also agent. The word agent. In cognitive psychology also they use the word agent. Social psychology. And also, for example, like if we talking about agent, like the person who sell the house, for example, sell the properties agent, for example, that is, I mean, the middleman, the one that find the buyers, for example, or find the sellers, that is also agent. So how about the agent that we talk in computer science or artificial intelligence? So why agents and what are they in the computer science? Do they bring us anything new in modeling and constructing our application? So whether is it agent helping in computer science, or is it by having the agents is helping or bring us something new in modeling or constructing our application? So much discussion of what software agents are and how they differ from programs in general. So basically, this agent is quite sometimes already, but the thing is it always update. When the new technology comes in, so they can fit in with the new algorithm, something they can fit in the agent. So that's why it's always the knowledge always update updated. Yeah. Okay, what is an agent in computer science? There is no universally accepted definition of the term agent. Okay, there is no universally accepted definition of the term agent, and there is a good deal of ongoing debate and controversy on the subject. Of course, when we talk about the definition, because we have many researchers, many professors out there, okay, they come up with their own definition. Of course, we cannot agree to to universally accepted definition. Some people say, okay, this is the definition of agent. Some researchers, some professors say that different. So, are all computational agents are intelligent? Okay, it appears that the agent paradigm is one necessarily endowed with intelligence. Are all computational agents are intelligent or not? So that's the thing, because some researchers, some professors, they says when we talk about agent, must be intelligent. Yeah? Some what do you call it? Some opinions that agent can be intelligent, agent can be not just normal agent, not intelligent. Yeah? So agent equals more often defined by its characteristic. Many of them may be considered as a manifestation of some aspect of intelligent behavior. So, so what it means here, many of them may be considered as a manifestation of some aspect of intelligent behavior. Means that at least the agent, they have some aspect or characteristic which is intelligent behavior, not just like a normal system. That's why it comes under artificial intelligence. Okay, agent definition. Most often when people use the term agent, they refer to an entity that functions continuously and autonomously and in an environment in which other processes take place and other agent exists. So this is according to Shoreham 1993. It says that most often when people use the term agent, they refer to an entity that functions continuously and autonomously. Yeah, continuously means that it continuously, yeah, it's not stop and then running again, stop again, but it says here continuously and also autonomously. Autonomous means that it's automatically controlled. Means that, for example, like autonomous car means that the car without driver, without the intervention from what they call this, from human, so they can interact or they can what they call this, react on its own. In an environment in which other process take place and other agent exists. So this is the definition of the agent. Another definition by Russell 1997, an agent is an entity that senses its environment and acts upon it. Okay, so what it says there is an entity that senses, means that it has the sensor that can sense the environment. The environment can be what the system is inside. It can sense what is the environment and act upon it. So that is the definition by Russell 1997. Okay, today is Sunday. In Johor is you are working on Sunday, right? But in KL we are still on what do you call this, on holiday. That's why a good timing here means that I can give talk on Sunday. Okay, another interpretation by his or definition by his of 1995, intelligence agents continuous continuously perform three functions: perception of dynamic conditions in the environment, perception of dynamic conditions in the environment, action to affect conditions in the environment, and then reasoning to interpret perceptions of problems, draw inference, and also determine action. So, according to this definition, it says that intelligent agents continuously, continuously perform three functions. One is perception of dynamic condition, means that we try to sense the condition or try to understand the condition or dynamic condition in the environment, and then after that act or action to affect the condition in the environment, and then also reasoning to interpret perception, solve problems, draw inference, and determine action. So if we look into the definition, is very means that agent is something which is very intelligent. Yeah? Is something which is, can perceive, can act, and then can reasoning. So it's like a human. Yeah? So when last time when I read, when I did my PhD on and using the multi-agent, I was like is it possible to code or to come out with the using the software we develop or code this kind of system, which is very intelligent, very can reasoning, can do action continuously. So that's why when they give the definitions of something, normally it's something very high, very abstract. When we read and we see, is it possible or not? We are going to develop this kind of system. Is it possible? Huh? Something like it mimic or is copying the human can do. So it's very difficult. When it comes to coding, when you try to develop the system, we might have some elements of intelligence, but it is what we call it impossible. But by what you call is by the times people are doing research, and then it will develop, and it becomes intelligent. Yeah? Okay, according to the IBM agent, intelligent agents are software entities that carry out some set of operations on behalf of a user or another program. So here it says that intelligent agents or software entities is carry out some set of operation on behalf. Here is like the agent definition here is little bit similar like the properties agent, because when we have agent that act on behalf of us, yeah? We for example, like we want to buy the house, so we find the agent, so the agent is acting on behalf of the user or on behalf of that person. Yeah? So with some degree of independence or autonomy, and in doing so, employ some knowledge or representation of the user's goal or desire. So means that the agents have some degree of independence or autonomy. Autonomy means that he can make some small decision, for example. Uh, it's not fully, but here you see there
Oi,
is some degree of independence or autonomy
oi,
that
oi,
actually
oi, Ayan, bego lu.
and with some degree of independence or autonomy, and in doing so employ some knowledge or representation of the user goal or desire. Means that by the agents in doing that, employ some knowledge and also representation on behalf of the user goals or desire. Means that they say like we want to buy the house, so we tell to the agent say that I want the house like this, like this, like this. Means that we tell our desire, our objective to the agent, so the agent will find or try to fulfill that objective. So this what they call this definition is we can easily understand from this the IBM agents group. Yeah? Okay, agent. This is another definition by Woolrich and Jennings, 1995. Yeah? So this is also another gurus, what they call it, gurus of agent, Woolrich and Jennings in 1995. I think he's from UK. Last time he there was in Southampton University, but now I think from changed university. So agent actually is a hardware or more usually a software-based computer system. You can see here is either a hardware, also can be agent, or more usually a software-based computer system that enjoys the following properties. One is autonomy, means that agents operate without the direction intervention of human or others and have some kind of control over their actions and internal state. So according to the Woolrich and Jennings, it says the agent have these properties, means that autonomy, that they can operate without the direct intervention of human or others. Means that it can make decision or act according to without the intervention from human, That is autonomy. And then reactivity means that agents perceive their environment and respond in a timely fashion to changes that occur in it. Means that agents um, can understand or what you call sense what is happening in their environment and respond in timely fashion. Means that it can react fast. Timely fashion means that fast, very fast, yeah, to change that occur in it. So if there is a changes in the environment, so the agent will react quickly, yeah, according to the what is the change that it need to do. And then proactiveness. uh, The next properties, proactiveness means that agents do not simply act in response to their environment. They are able to exhibit goal-directed behavior by taking initiative. When we talk about proactive, we can compare to the human. You can see if someone is proactive, means that he doesn't wait until, for example, like you just wait, your mother asks you, go study, go and eat, then you go. So you wait for the what they call this any instruction, then you do. That is not proactive. But if you are proactive, means that someone that okay, he knows what to do. He goes here, try here, and at what time okay he needs to go to university at this time he needs to sleep. So someone which is proactiveness. So similar with the agents. So according to this guy, agent is proactive means that he's not waiting for instruction, but he will do it according to what he's supposed to do by taking initiative, by taking the initiative. So this is something which is it's not easy, yeah. If you want to build a software that proactiveness, reactivity, autonomy. And then the social ability, agents interact with other agents and possible humans via some kind of agent communication language. Means that the agents have kind of social ability, means that we can interact with each other, we can communicate with each other. It's not only on its own, but we can communicate via kind of agent communication language. So these are the definition by Woodridge and Jennings. And if you try to understand the properties, autonomy, reactivity, proactiveness, sociability, is something which is not easy or difficult to build up a system that have all these characteristics. Okay. Okay, identify characteristic two main streams of definition. Okay, there are two main streams of definition. One, define an agent as in isolation. Means that define agent is isolation means that it's not interact with each other, it's not communicate with each other. And another definition says that define an agent in the context of a society of agents in the social dimension, which is multi-agent system. Another definition says that where the agents is not only isolate, but they have many agents inside that, and also they can communicate, they can negotiate, they can interact with each other. So that's why they call it as a multi-agent system. Yeah, it's not only agent is only one, but in multi-agents it can be many agents, either the same type of agent or different type and different uh, ways that interact with each other. The two types of definition does not necessarily incorporate intelligence, must incorporate a kind of intelligent agents behavior, which is intelligent agents. Okay. There are also, in terms of the intelligence, there are also two types of definition. One says that it's not necessarily incorporate intelligence. So the agent is not necessarily must be intelligent. It can be just normal agent. It's not necessarily intelligent. Just do something which is normal function, normal work. And but another school of thought says must incorporate a kind of intelligent agent behavior, which is intelligent agent. Means that that agent must have some kind of intelligence. It's not like normal processing state. Send must have some intelligent behavior in that. Okay? So the agent characteristic, agents act on behalf of a user or another program. So the characteristics of agent is normally it interact or it acts on the behalf of a user or on behalf of another program. And then also agent is autonomous, and as I tell you that autonomous means that uh, agent can make their own decision. And then sense the environment and acts upon it means reactivity, means that it can sense what happenings around it, around the agents, and if there is any changes needed or any action needed, react. Then purposeful action. Purposeful action means that the agents have a purpose. Let's say if the purpose is to find the cheapest, for example, cheapest stock. So you will try to find the cheapest stock one by one. So means that they have the objective or the goals. The agents have their own goals. Yeah? So that's why it says here is proactivity, proactive. Yeah? And then it functions continuously, means it functions all the time. It's not like when we say, okay, you do, then the agent start doing that stop. Do again, you do. No, it's continuously. Or we call it as a persistent software. And also there are also type of agent which is mobile. Hello, testing, testing, is it okay?
Yeah, I can hear you.
Okay. Okay, and then agent has goals and also rationality, and also it can have reasoning and also decision making. Means that it can reason. Reasoning means that everything, whatever info comes, it can reason what actually is happening, and also it can also do decision making. So this under this we call it as a cognitive. Yeah?
Okay,
And then
Samad,
also agent, yeah.
can you share again your slide? I cannot see.
Oh, okay, okay. I think you were disconnected just now. Uh,
Yes. Yeah.
okay,
Full
okay.
screen.
Full screen again.
Correct.
I think just now we were disconnected. Okay, then also agents can learn, can adapt, and then also agent can interact with other agents. So that's why we call it. We can socialize with each other in social dimensions, and also other basis for intelligence. So according to their purpose, so maybe the agents have some kind of intelligence according to what is the purpose of the agent. Eh? Okay, agent environment. So you can see here on the left, you can see we have agent here, and then the box we have environment there. So the agent receive the input from the environment with the sensor input, and then agent also will uh, rationalize and do some action output according to what the agent received from the sensor. And then environment properties is either accessible versus inaccessible. So whether it can be accessed or the properties cannot be accessed, inaccessible. It can be deterministic versus non-deterministic. And then episodic versus non-episodic, static versus dynamic, open versus closed. So these are the environment properties. Yeah? So of course the agent normally, when we talk about agent and we try to compare with the object-oriented concept, there is in object-oriented, if you are talking about object-oriented concept in software, one concept in object-oriented is encapsulation. Encapsulation means that we don't know what actually happening inside that object, but we still can communicate. So the same thing also in agent, we actually don't know how is the process of decision making inside the agent, what are the process, but that one is encapsulated or is hide inside the agent. Okay, the multi-agent system, we have agent, now we have multi-agent system. Yeah? It's many entities or many agents in a common environment. So let's say in this example, you can see that we have environment here where like a robot talking to each other. So it's like the agent is something like that where we have a common environment and we have many agents inside that. So let's say if for this example, uh, you can see that in the picture here is the robot, one robot and then another robot and then got another robot and then interact with each other. They interact with each other. So so between each other, the agents communicate with each other. So that's why we call it as a multi-agent system. Means that we have many agents. It can be same or the same type or different type, but they are communicating with each other, either negotiate with each other, either they interact with each other. So that is multi-agent system. So multi-agent system, many agents in the same environment, interactions. Okay, interaction among agents. So they are interact within each other within agents. So we call it as a high level interactions. So the interaction can be either coordination or communication or organization. Coordination means, let's say you have many agents that you can coordinate with each other in order doing some or one task. Yeah, we coordinate in order to do some task. And then or maybe interaction can be communication between one agent or many agents to communicate with each other, and or interaction for organize something. Yeah? So coordination is collectively motivated or interested or self-interested, means that they have some interests in common. Maybe they want to, let's say, in the game of soccer, right? Football, let's say the robot that represent the that represent a player, one player, and then they want to score the goal, score the what you call it, the ball, try to kick the ball into the goal. So that's why they try to coordinate with each other in order to uh, get something, achieve something. So it's either own goals or indifferent. Own goals, they have their own goals or different goals. Or own goals, whether it's like a competition, competing for the same resources, or they have their own goals, competition or contradictory goals, own goals or coalition. So you can see here the coordination, they have different motive, depends on what actually their agent's objective is. I mean, depends on their own goals. Either they want to achieve something, or the agents want to achieve something, or maybe one agent want to achieve different thing, or maybe the same agent, all they want to get the same resources. Yeah? And then communication. So the agents, in order for them to communicate, they have a communication protocol. So in agent also they have communication protocol and also communication language. So for example, like we, like human, when we talk, we have the communication language. For example, let's say if we talk in Bahasa or in Malay, or we talk in English, we have the communication language. And also we have the protocol. In order for us to talk, what are the protocol, what are the language, what is the sentence looks like, what is the grammar, so that the other side can understand. So the same thing also in communication between agent to another agent, they have the protocol, they have language, and then they also can negotiate to reach agreement. Means between agent, uh, the agents can negotiate with each other in order to reach the agreement. Then it comes the ontology. So what is ontology? This is if this is another story. Ontology, huge. If you want to study ontology, is something different. Ontology is like you see when we uh, talk to each other or communicate with each other, they must have some terms with that between the agent they can understand. So that is we call it as ontology. Okay, then organizational structure means that they between the agent also they can have organizational structure, whether the structure of the agent is either centralized versus decentralized. So centralized means that, for example, like it's centralized means probably it comes from uh, one uh, instruction, then it goes down, or either it versus decentralized. Decentralized means that their agents have their own uh, what I call this autonomous, so they just communicate with each other. And then hierarchical or markets. So hierarchy means that it have their own hierarchy, and or maybe by using market. Market means that okay, the market uh, mechanism. Let's say the agents negotiate with each other. Let's say one agent negotiate with another agents. So the way they negotiate is how is it we did by using the market mechanism. It's like market mechanism is like if according to the agent who give the lower price, for example, the market, right? If you're talking about the same price in the market, so the one according the one that sells something which is very cheap, so maybe that will be buy by the other parties. So they try to negotiate. Let's say the buyer want low price, but the seller want high price. So they try to negotiate until they get agreed to the terms. Yeah? So they try to mimic or they copy the market system and try to implement in the organizational structure of the agent. So that's why when we talk about agents, that's why it involves a lot of theory from different backgrounds. For example, like physics, economic theory. For example, they bring on the market system theory inside the agents. Communication theory they bring into the agents where agents can communicate with each other and negotiate with each other. So different type of knowledge and they try to bring into the agent. For example, like cognitive, then they try to bring inside the agent. So maybe in the future they try to bring in the theory and then try to apply in this agent system. So how do agents acquire intelligence? Okay, cognitive agents. So like cognitive. If you study cognitive, what is actually the cognitive? Cognitive from psychology means that you know how the human can thinks, how the human can reasoning, or how the human can make decision. So they try and bring this theory of cognitive into and make the agents become cognitive. The model of human intelligence and human perspective of the world, it becomes characterized and intelligent agent using symbolic representation and mentalistic notions. So for example, like knowledge. John knows humans are mortal. So inside the agents, they try to bring all this knowledge, beliefs, desires, goals, intention, choices, commitments, obligations. So all this actually is what human can do. Right? Human have knowledge, Human have beliefs, humans have desires, have goals, human have intention also, and also human have choices, and then human have commitments and obligation. All these are what you call this the characteristic of human. So what they're trying to do, bring this quality, bring this characteristic into implement into agents. That's why it's very difficult. Means that at the end of the day, actually they want to make agent as if like a human that can think, can be, have belief, have desires, have goals, have intention, have choices, commitment, obligation, all this. So it's, I mean, maybe it's just a theoretical for the moment, but it comes before the implementation. Normally, the people come up with the theory first. Okay, next. Okay, premises such a mentalistic or intentional use of agent, a kind of folk psychology, is not just another invention of computer scientists, but is a useful paradigm for describing complex distributed system. So means that what I'm trying to say here means the agent is just another, it's not just like an invention of computer scientists, but it's a useful paradigm for describing the complex distributed system. And the complexity of such a system, or the fact that we can not or know or predict the internal structures of all components, seems to imply that we must rely on any strict intentional explanation of system functioning and behavior. So that's why this is the theory that how they make the agents become intelligent, yeah? Because of the complexity of the system, and then trying to bring all the qualities of human inside the agents. So that's why they, according to the theory, it can make the agents become intelligent. Okay, and then okay, that was the cognitive agents, but this one is reactive agent. Comparison with AI, alternate approach of realizing intelligence, the sub-symbolic level of neural networks, and also its alternate model of intelligence in agent system. So it goes to the reactive agents. It is simple processing units that perceive and react to changes in their environment. So this kind of reactive agent, just now is cognitive, but this is a type of agent, they call it as a reactive, where the agent is perceive and react to change in their environment. So they perceive what actually happened in their environment, any changes, any, I mean, by using the sensors, they can get the input from the environment, and then they react to the changes. Do not have a symbolic representation of the world, and do not use complex symbolic reasoning. Means that the reactive agents, it doesn't use the symbolic representation of the world, and it doesn't use complex symbolic reasoning. And the advocates of reactive agent system claims that intelligence is not a property of the active entity, but it is distributed in the system and stems as the result of interaction between the many entities of the distributed structure and the environment. So what the advocates, I mean, that people who are support on the reactive agents of the theory of reactive agent, means that they says the intelligence of agent is not of the property of the entity itself, or it's not the property of the agent, but it comes, but it is distributed in the system and stems as a result of the interaction. Means that the intelligence comes when the agents can interact with each other, and also they can do tasks between in distributed system. So that is the people who support this reactive agents. Yeah? Because some people say the agent must be cognitive, where they copy the humans, what you call this, humans, uh, the humans brain. But this one, the reactive agent is not that intelligent, but it's only react to the environment. Okay, I'm not going to do this. Yeah. Okay, another one is emotional agents. Is a computable science of emotions. Okay, there is also research that on the emotional agents. a computable science of emotions. Yeah, means that they come out with the agents which have emotions. Yeah? Visual actors, for example, like listen through speech recognition software to people and it respond in real time with morphing face, music, and speech. For example, like the agents listen to what people talk or tell tell the agents, and then the agents can respond either in real time with morphing face. I mean, let's say if the user was telling about something happy, then maybe the face come out with happy, and then or music, text, and speech. Right? So it means that the agent can understand the emotions and react with the emotion as well. Right? So appraisal of a situation as an event, for example, it can appraise according to the situation of an event. For example, like event when there is a joy, means happy or distress, probably with the uh, stress phase. Yeah? Presume value of situation as an effect affecting another, happy for gloating, resentment, jealousy, envy, sorry for, an appraisal of the situation as a prospective event. I mean, the hope and fear. Appraisal of situation as confirming or disconfirming an expectation, where they have a satisfaction, relief, fears, comfort, and this uh, disappointment. Yeah. So means that the agents can react according to the emotion. Yeah? Either the appraisal of situation as an event with joy, distress, or appraisals of the effect everything another with happy for working resentment, appraisal for where you have a situation as prospective event, they have hope, fear, all this satisfaction, release, all these are the emotional agent. Yeah? And then manifest the temperament controls of emotion means that the agents can manifest the temperament control of emotion. They can control the emotions. Yeah? So this is we call it as an emotional agent. Yeah? Okay, mass or multi-agent system links with other disciplines. You can see that the multi-agent system here links with other disciplines. So you can see here multi-agent system in the middle where it has interact or links, for example, like decision theory. In decision theory, either is autonomy, rationality, artificial intelligence or distributed artificial intelligence, where it has rationality, learning, productivity, cooperation, activity, and then discipline of psychology, where character of the agents, activity of the agents, and then the sociology of theory sociology, organization of the agents, and then the discipline of distributed system, where agents have communication, mobility, and then OOP, object-oriented programming, also in agents, object programming, then economic theories where they use market. So you can see that the agents links with other disciplines. Yeah, in artificial intelligence, decision psychology. Okay, areas of R&D in multi-agent system. So if you want to do research in multi-agent system, of course there are wide area of research. For example, the first one, agent architecture. So what is the best architecture for the agent? Is it, what are the new architecture? What are the suitable architecture for the agents? And then knowledge representation means that how agents represent the knowledge that they have, either representation of the world itself or the other agents. And then communication, how the agents can communicate with each other, what are the language that agent can use in order to communicate, what are the protocols can be used, and then also how agent plans, for example, task sharing with each other. Let's say you have a group of agents, how you can share the task between the agents, and then how you share the results, or how you plan, distributed planning between the agents, and then coordination of agent distributed search decision making in order to make the agents to make decision. It can be using negotiation, market system, coalition, formation. So all these are the decision-making process. Or maybe you want to improve the current system or the current way of, or you want to come up with a new, and then the learning agents also can learn. So how agent can learn from the environment, from each other, and then also the organizational theories, how the agent organize with itself in groups. So what are the theories, and then the norms of the agents, and also the trust and reputation, the trust between agents, how they trust each other, and also the reputation with one agent to another agent. So these are example of R&D, research and development in multi-agent system, that if you want to do or you want to explore on the agents development. So, okay, areas of R&D also multi-agent system. It can be, for example, in multi-agent system, in implementation, for example, agent programming, uh, how to program, how to code the agents, and then the paradigm of the agents, the language that you can use, and then the agent platforms. What are the agent platforms in order for them to interact, and the middleware that you're going to use, the mobility of the agents, and then the security, the security of the agents. Of course, we need to look into the security aspect also, because the hackers always can goes into also agent system and try to do something. And then applications, the application of multi-agent system, it can be when we talk about the industrial application, we can apply the multi-agent system like real-time monitoring and management of manufacturing and production process, and telecommunication networks. Also, we can use agent, and then transportation system, electricity distribution, and etc. Yeah? Actually, we can apply to any domain or any area, as long as we want to make it intelligent. Huh? And then business process management, decision support, also we can apply agent as well in e-commerce, e-markets. Then also we can apply agents on information retrieving and also filtering. We want to retrieve the information and also filtering, we can use agent as well. And then HCI, human computer interactions, CAI, web-based learning, PDA, etc. All this, actually the application is very wide. Yeah? So it's not only this. It means that any anywhere actually, yeah? Everything under the sun, as long as if you want to apply in one of the agents, it can be either in software or hardware. Okay, this is some example agents in actions. For example, in NASA, Earth observing one satellite, which began operation in 2000, was recently turned into an autonomous agent test bed. So NASA used autonomous agent to handle tasks that appear simple but actually quite complex. For example, one mission goal handled by autonomous agent is simply to not waste fuel, but accomplishing that means balancing multiple demands, such as staying on course and keeping the experiments running, as well as dealing with the unexpected. So NASA used one autonomous agent in order to the mission is to not waste fuel. That's only the mission, but it has very great impact. So what happens if you run out of power and you are on the dark side of the planet and communication system is having a problem? It's all those combinations that make life exciting. Says Steve Shin, principal scientist for automated planning and scheduling at NASA Jet Propulsion Laboratory. So that is one example. And then PECSCM negotiation was one of the key agent capabilities tested at the conference trading agent competition. In one contest, computers ran simulations of agents assembling the PC. The agents were operating factories, managing inventories, negotiating with suppliers and buyers, and making decisions based on range of variables, such as the risk of taking on a big order, even if all the parts were not available. If an agent made an error in judgment, the company could face financial penalties and order cancellation. So this is application of agent in trading agent competition, where one contestant that it runs the simulation of agents assembling the PC. So it's not the human, but the agents doing the assembling the PC. So the agents were operating the factories, managing the inventories, negotiating with supplier and buyers. Means that you don't need the people to do this operating the factories, but agents that will do that operating the factories and also managing the inventories. One agent that manages the inventories, and one agent negotiates with supplier and buyers, and also making decisions based on range of variables. So this is just a simulation in trading agents competition. So very interesting. But if we can implement in real situation where basically if the agents can do what humans can do, then we can hand over to the agent actually. Yeah, to do. Okay, butler agents. Imagine your very own mobile butler able to travel with you and organize. A butler is like a person that are helping you, able to travel with you and organize every aspect of your life. From the meetings you have to the restaurant you eat in, means that something like a personal assistant to you. Okay? If you have a mobile personal assistant that can help you to organize your travel, order your food. So the program works through mobile phone and is able to determine users' preference and use the web to plan business and social events. So the agent here is very clever that can able to determine user preference and use the web to plan business and social events. And like a real life butler, the relationship between phone agent and user improves as they get to know each other better. And the learning algorithms will allow the butler to arrange meetings without the need to consult constantly with the user to establish the requirements. So it's like the agents do on behalf of you. Try to arrange a meeting with you, try to order food for you. I think it's very interesting if it can be uh, implemented. Robocop, Robocop agents. The goal of the annual Robocop competition, which have been in existence since 1997, is to produce a team of soccer playing robots that can beat the human world champion soccer team by the year 2022. So just now that the robot play soccer, and actually you can do
Okay, Dr. Samad, you may proceed.
I think I'm gonna stop here. Let me.
Yeah, it's finished.
I think it's enough until here because I think if I talk more is more than enough. They cannot get too much knowledge at that one time. I
All
think
right.
I'm gonna open for Q&A. Is it?
Okay. Is there any question? You can ask the speakers for the session. Everyone.
How many participants already? 26
It's
participants.
26. 26 is about.
Okay.
All right.
Very
Any
good. Very good.
question? Any question, guys?
Is it most of the students are from electrical?
Mix.
Section
Some of them are
mix.
computer science, some of them are electrical engineering.
Oh, okay. Some postgraduate, some
Some
undergraduate,
postgraduate, some staff.
some stuff as well.
Yeah. Right. So no question?
Yeah, if you want to contact me, you can take my email, or
Okay.
if you want to ask any questions, I'm gonna write in the chat box my email address. I think
Okay.
Abdul
So
Samad at UCSI University.edu.my.
okay, so the email has been given at the chat area, so you may find the emails and contact the speakers if you have any question or you want to ask anything about the agent. So if there is no question, I think we can end the session now. So thank you very much for the Associate Professor Dr. Abdul Samad for the interesting talk about the agent itself. And then hope the student can get some benefits on the what is agent and how to differentiate between agent and other object oriented things. And then so with that I end up. So please record your attendance as the link given in the chat area. So maybe Dr. Samad can share the slide after this to want to give some
Okay.
guidelines to the students. All right, so thank
Mhm.
you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, I think there is one question here.
Is there a
The technology
question?
of intelligent in the chat box. The technology of intelligent agent is crucial as it builds fully robust autonomous software
Yeah.
generation. Is there any potential threats and challenges of intelligent agent towards major apps such as agent negotiator or agent shopper? So of course there is any threats and challenges to that, yeah, because when we talk about software, of course the security is something is challenging because mm, when we call the thing as software or hardware, there always can be what you call this uh, hackers that it can go through the system or try to manipulate the agents. That's why one things about the agent is we also need to look into the security aspect of the agents and also the trust of the agents between how they can negotiate on behalf of the user and who or which agent that they can trust and how to make sure that that agent can be trusted and how to all these things is still on is ongoing research. So it is interesting. It's always ongoing research that we can uh, try to improve the agent technology. So we hope in the future that all this issue we can find some solution for this. Okay, guys, thank you very much. If
All
you got
right. Thank
anything, you can
you.
email me.
Thank you very much, Dr. Samad.
Okay, thank you. Assalamualaikum.
Waalaikumsalam warahmatullahi.
Mm.